Hi, and in today's session, we're going to talk about redox reactions. So let's start off with a brief background to oxidation and reduction, which is the short to redox reactions. So oxidation is known as the addition of oxygen, and reduction is known as the removal of oxygen. So we can see here this reaction of copper and oxygen gives us copper oxide. So it is clear to us that copper has been oxidized as it has gained oxygen in the final product. But what has been reduced? So in order to know what has been reduced, we need to write the ionic equation in order to analyze the changes that are taking place during this reaction. So if we were to write the ionic equation, and let's do that now. So it is Cu stays as is since it's in the solid state, and oxygen is a gas. We only break down ions when in aqueous state. So CuO, which is copper oxide, is also in the solid state. So nothing has changed. But we know for sure that copper had zero charge, while in the ionic state, when it's in the ionic compound, it has become Cu plus, Cu2 plus, since it's copper 2 oxide. So copper 2 plus. While oxygen molecules in the gas, they have split up and they have reacted and become oxide ions, which had a charge of O2 minus. O2 minus in this copper oxide. And so we can see that copper has went from 0 to Cu2 plus, which means it has lost electrons, which we will come to later. And it also has gained oxygen. So you can say copper has been oxidized and the other species have been reduced. And we can define this in terms of electron transfer, electron loss and gain, and we'll talk about this in a few moments. Let's take a look at another example that seems complicated. However, it is very simple. So we have iron oxide plus copper monoxide gives us iron in the solid state plus carbon dioxide gas. So what has been oxidized and what has been reduced in this case? You can see that iron oxide had an oxygen, while when it turned into the products, we only have iron. So it has lost electrons. Removal of oxygen is reduction. And so iron oxide has been reduced, while copper monoxide has gained an oxygen atom. And so it has been oxidized. And that's it. That's in terms of removal and addition of oxygen atoms. While we can expand the definition of redox and say that oxidation is the removal of a hydrogen atom and reduction is the addition of a hydrogen atom. Taking a look at this example, we have chlorine plus hydrogen sulfide gives us hydrogen chloride or hydrochloric acid plus sulfide. So chlorine has went from chlorine in a normal state, just a simple chlorine element, diatomic, to HCl. So it has gained a hydrogen atom. And we said that addition of a hydrogen atom is reduction, which is the opposite of oxidation in terms of oxygen removal and addition. Also, when we come to electron transfer, it is also the opposite of when talking about redox in terms of oxygen. So when we define redox in terms of hydrogen and electron transfer, it is always the removal of an electron, or the removal of a hydrogen is oxidation, and the addition is reduction. So hydrogen sulfide have become sulfur only, and so it has lost a hydrogen atom, and so it has been oxidized. So in conclusion, redox reaction is a reaction that involves both the reduction and oxidation reactions. Now, if we expand the definition furthermore of redox reactions, and we can put it as in terms of electron loss and gain. So, just a second, okay. So we can see here that we can short the electron transfer in oil reg, which is a statement that stands for oxidation is the loss of electrons and reduction is gain of electrons. Okay, so taking a look at this example of the displacement reaction of zinc and copper sulfate, where there's obviously no transfer of oxygen since there is no oxygen in the reaction as a whole. So zinc plus copper sulfate gives us copper in the solid state plus zinc sulfate in the aqueous state. Okay, so, all right. So in order to know what has been lost, oxidized and what has been reduced, as we said before, we need to look at the ionic equation. So here's the ionic equation. Now, I'll write the ionic equation again for you to see how here we have a sulfate ion, but here we don't have that. This is because sulfate is a spectator ion. A spectator ion is the ion that does not change during the reaction. It's in the products, same as in the reactants, and vice versa. So we have zinc stays as is since it's in the solid state. And we have copper sulfate is in the aqueous state. And so we'll break that down into ions. So copper has a charge of +2, since SO4 has a charge of -2, and so when they cancel out, the valence electrons cancel out when reacting together. And so SO4, 2-. This gives us in the products a copper in the solid state, so that shall not be broken down into ions. And zinc sulfate is in the aqueous state, and so zinc has a charge of +2, while sulfate has a charge of -2. So now we can see that SO4 is in the reactants exactly identical as in the products, so they cancel out. While here, copper and zinc have been changed and are different. So you can see that zinc, okay, right. Okay, so you can see here this final ionic equation where zinc has an increase in the number of oxidations or oxidation state, which we'll talk about in a bit. So zinc had a charge of 0 at first, and it has changed into +2. So it went from 0 to +2. And this means that it has lost or gained electrons. It has lost electrons because it have become more positive, while Cu has lost or gained electrons as it has become more negative, or it has simply gained electrons because it has a decrease in the oxidation state or in this charge number. So as I said, 0 to +2, this means it's an oxidation reaction. And Cu +2 to 0, it's a reduction reaction. Okay, so taking a look at these equations are called half redox reactions or half redox equations. Okay, these represent in details of each ionic species what happened. Either it has lost or gained electrons. You can see here that it has lost electrons. Zinc has lost electrons. So it has been oxidized. Cu, copper, has gained electrons. So it has become reduced. Okay, on to the next concept. And here we'll talk about oxidizing and reducing agents. A very simple and nice concept. So we have here this equation of a magnesium plus oxygen gives us magnesium oxide. And we can define this equation either as a redox equation or reaction in terms of oxygen transfer or electron transfer. And you can see that Mg has reacted with oxygen, so it has gained oxygen, and so it has been oxidized. And since we cannot see what has been reduced, we need to take a look at the ionic form or the electron transfer. So we can see that when Mg and O2 have been in their element pure form, and so they have a charge of 0, and once they're in the ionic compound, Mg has a charge of +2 and O2 has a charge of -2, and so Mg has been oxidized as it has gained electrons, and O2 has lost electrons. Mg has lost electrons, it has become more positive, and O2 has gained electrons as it has become more negative, and so it got reduced. So a species that has been oxidized is called a reducing agent, as it has reduced the other species. And also oxygen here is the reduced species, and it's also called the oxidizing agent, which has oxidized the other species. Okay, so this is the oxidizing and reducing agents. Taking a look at another example. So it is said that chlorine is a good oxidizing agent. So we have a reaction of chlorine plus potassium iodide gives us iodine plus potassium chloride. And in this reaction, chlorine displaces iodine. That's why it's a strong oxidizing agent, a good oxidizing agent, as it displaces iodine. And let's see how this is an oxidizing and reducing agent. We cannot figure this out only from this equation. We should know the ionic equation of this reaction. So here chlorine stays as is. It's in the aqueous state. This is a solution as a whole. This reaction is occurring as a in solution. Iodine, here we have K plus, Cl minus, iodine 0, chlorine 0. And so K plus and K plus cancel out, so they're spectator ions. And then we have chlorine turns into Cl minus. And you can see that they have gained electrons to become chloride ions. So they have become more negative. And so let's write it here. So it has gained electrons, so it has been reduced, while the iodide ions have lost the electrons, so they have become more positive, and so to form iodine. And so they have been oxidized. The iodide ions have been oxidized to form iodine. Okay, now if we take a look closely at those reactions, we can see that we can even define oxidation further. As we mentioned a while ago, we are talking about oxidation state, where it is loss or gain of electrons, but we are writing a charge on the number to show if redox, oxidation, or reduction have occurred. All right. So oxidation state. So oxidation state is a number given to show whether an element has been oxidized or reduced. So it's a number simply given to an element to show whether it's an oxidized or reduced. And the oxidation state of an ion is simply the charge on the ion, as we mentioned. So during this reaction that you see right here, the oxidation state of zinc, it was a 0, and it has increased by 2. As you can see in the products, it's increased by 2 from 0 to +2. Meanwhile, the oxidation state of copper has decreased by 2 because it goes from +2 to 0. So now we can name the reduction and oxidation reactions, where zinc has lost an electron, so it has become oxidized, and Cu has gained an electron in order to become reduced. Now, taking a look at this equation, the first thing that we need to do, as we said, is to write the ionic equation of the reaction. And the ionic equation is the following. So you can either write the ionic equation or simply write the charges above, because K will cancel out either way. But let's not mention spectator ions right here, and let's just focus on the oxidation state. So writing the charge of each element in this ionic solution, we have chlorine gas plus potassium iodide, and potassium is in group 1, so it has a charge of +1. Iodine is in group 7, so it has a charge of a -1. And iodine in the pure form has a charge of 0. Excuse me. While in this aqueous solution, potassium has a charge of +1, and chlorine is in group 7, so it has a charge or an oxidation state of -1. So K potassium ions cancel out. We're left with chlorine, and the reactants plus iodine gives us iodine plus chlorine. So we can see here that chlorine displaces iodine to form potassium iodide solution. Let's consider the changes in the oxidation state that occur. So you can see that the oxidation state of chlorine changes from 0 to -1. So it has decreased. So chlorine has been reduced to chloride ions. While you can see that iodide changes from -1 to 0. So it has increased. So iodide ions have been oxidized into iodine ions. So finally, oxidation is the increase in oxidation state of an atom or an ion, and reduction is the decrease in oxidation state of an atom or an ion. A very brief summary for what we talked about is redox. And redox reactions can be defined into 3 ways. We're either talking about the addition or removal of oxygen atoms, or the addition or removal of hydrogen atoms, or electron transfer, which is also expressed in oxidation state, or which is the number given to show whether an element has been oxidized or reduced, oxidation state. And also we said that when oxidation is gained, is added, this is oxidation, And when it's lost, this is reduction. While in hydrogen, it is the opposite, where if we add hydrogen atoms, the species has been reduced, while when removing hydrogen atom, it has been oxidized. And in electron transfer or oxidation state, when oxidation state increases, this is oxidation. So the number goes up, which means it has lost electrons. And so it has been oxidized. While in, for example, taking a look at what we said here, we have copper. When it goes down, so electrons have been, the species have gained electrons, so the oxidation state has decreased. It means the species has been reduced. And that was all. Thank you for joining me today in this session. I'll see you in the next. Bye-bye.